Hello everybody and welcome back to SkySaga Alpha 9. It is time for another Tutorial Tuesday. So behind me I have a new piece of Lumostone kit set up, and today we're going to be going through and talking about that. So what this thing is, it's called a sequencer, or maybe even more accurately called a shift register, but for what we're going to be doing, it is going to be called a sequencer. So basically what this thing does is it runs things in a sequence. So every time you step on this pressure pad, it moves from one light to the next in sequence. So it's going to go 1, 2, 3, and then it's going to come all the way back and start at 1 again. So basically this is like the light sequences that we've set up before, but rather than being automatically timed, it is timed off a pressure pad. Now the reason this is important is because you can then use this pressure pad to set up a whole system whereby multiple doors are opened at various different times by pressing a single pressure pad. And it's also useful for things like calculators and adders and things, where one step has to be done first and then the next step has to be done and then a final step has to be done. This way you can use something to trigger an input, and once whatever that particular sequence has been done, you can then trigger the next sequence to happen by flipping the sequencer from one to the next. So in terms of like a calculator, for example, you need to copy the number that goes in, the first number that goes in. You then need to copy the add or subtract or multiply, and then you need to copy the second number that goes in, and then you need to go through and actually work out what you're doing, and then you need to go through and actually do those things. So this is where a sequencer comes in quite handy, because you can use these things to do all of those steps in an actual sequence. So you can have it set up so that, you know, step number 2 is read in what you actually want to do, add, subtract, multiply, whatever, and then once it's realized what it needs to do, it sends a little trigger to this sequencer, and then it reads in the next piece of information, and so on and so forth, and you can kind of flick through these things. Like I said, it's also quite useful for puzzle making. So obviously these outputs, you can do whatever you like with them. So you could actually set it up so that you have like a little square room, and when you step on the first plate, one door opens up and that activates a second pressure plate, and then you can step on that, and stepping on that and then stepping on this first pressure plate again closes the first door, opens another door up, and you have to keep doing that until you get to the right door to go through on into the next part of the puzzle. So this thing is actually pretty similar to a counter in terms of what you actually need for each section. And as before, this thing is actually made in little sections, so you can just kind of cut and paste these over and over and over again to get longer and longer sequences. I've only made a 3-byte sequencer right here, and that's because this is just a little bit of a demonstration. When we go through and do the build, we'll probably only build a 2, we might build a 3 sequencer, but I need to wait for the sun to come up and get all the materials so that I can show you guys what goes into each particular step. And as I said, these are just basically carbon copies of each other, so once you know what goes into one, you know what goes into your whole circuit. You just need to multiply it out by however many steps you're doing, and then you can build it as long as you want. So let's grab some materials and check that out. Okay, so to build this one, what we're going to need is per sequence or per light or per door or per output, whatever you want to do, you're going to need the actual output itself, which of course can be a whole nother lumoweb. These things can be used to trigger certain lumowebs one after the other, as I was mentioning before. So you need your output, whatever your output is going to be. Then you're going to need a single latch, 2 AND gates, and 1 NOT gate per output that you want to run. On top of all of that, you need 2 NOT gates to act as a node to send the signal from the last latch all the way through to the first latch. And then you're also going to need 2 AND gates and 3 NOT gates to set up the start of this thing, and then also the input to this. So this is going to make 2 rising edge pulses, one of them triggered by your input. In my case is going to be a pressure pad, and one of them is going to be triggered by an extra NOT gate. So that's going to be our kind of jump start condition. When the island loads or when everything resets, that NOT gate is going to power that quickly power that rising edge pulse, and it's going to turn one of the lights on, which is then going to let us run through these things in sequence. So very basically how this stuff all works is it essentially has all of this stuff hooked up so that when that pulse comes through, this latch here copies what this latch is currently looking like And as it's attempting to do that copy, this latch is copying what the previous latch in the chain, this guy, is doing. And once again, this guy's also copying what this guy is doing. So essentially, all we're doing is we're turning a light on, and then we're kind of copy and pasting that down and down and down and down. Or more accurately, we're cutting and pasting that so it kind of cycles through and through and through. So to start with, what we're going to do is we're actually going to put in our first rising edge pulse. Now this is going to be our input rising edge pulse, and to start with, I'm just going to hook all of this stuff up. So we want to place down a rising edge pulse, as we've done a lot before, but of course I'm going to redo that on camera. So here we go, we've got our pressure plate. Pressure plate goes into the NOT gate, and I seem to be having a sound bug again, but pressure plate goes into the NOT gate and into the A side of the AND gate. Then the NOT gate goes into the B side of the AND gate. So that gives us our nice little rising edge pulse. So that's a good start to this whole system. Now, the next things we're going to want are our actual latches and outputs set up. So I'm going to quickly grab my outputs as well. So we're going to throw a latch down, and then we're going to go behind each latch. Sorry, that was an output. We want a latch instead. So we're going to throw a latch down, then behind each latch we're going to throw 2 AND gates, and then behind one of those AND gates we're going to throw a NOT gate, just like this. And then we're going to do the same thing over here. So this time we're going to put the latch here. I like to spread these type of circuits out just so that I know I'm not making mistakes and I can see where all of the lines are going and just be 100% sure that everything is exactly where it's supposed to be. So here we go. This is now going to be 2 sequences set up. So we've got one there and one here. So this is just a little layout that I'm using. Now I'm going to quickly set up the third one as well. So it's, once again, just the latch first, and then one NOT gate, kind of one block either side, and then, sorry, one AND gate either side, and then a NOT gate behind one of the AND gates. Now when we go through to wire all of this stuff up, the wiring itself is pretty simple. NOT gate goes into the A side of the AND gate, and the AND gate runs through into, so the AND gate with the NOT attached to it runs through into the off position, and then the AND gate without runs through into the on position. So what's going to happen is that these AND gates are going to be hooked up to the pulse in just a second, but they're also going to be hooked up to the next, to the previous line in the sequence. So we'll talk about that in just a second. So once you've got that particular setup hooked up, we're going to do that for all of our systems. So once again, NOT gate into the A side up here, and then AND gate into off. And then this other AND gate, the free AND gate that's not hooked up to anything, goes into the on side. And moving on down to the third and final one, we're going to do all that again. So NOT into the A side of the AND gate into the off part of the latch, and then the lonely AND gate goes into the on side, just like that. Now that we've got all of these done, it is time to do some interlinking between these three. So what we're going to do first is we're going to set up a little node at the back here, which is done with 2 NOT gates, and you just link those 2 NOT gates together. So this is what's going to run our signal from this latch all the way back through to this latch. Now the reason I'm doing this is because this makes this web a lot easier to understand as you go through and look at it, and it pulls these lines out and around and back over here so they don't kind of pass through all sorts of other things and kind of mess up your web and just kind of make the wiring all messy and not really easy to understand. So what we're going to now do is we're going to take the first latch and we're going to run the output of the first latch into the NOT gate, and then we're also going to run that into the A side of the lonely AND gate on the second latch. So here you go. That's how this should look. So we've got from the first latch we're going to the NOT gate on the second and to the lonely AND gate on the second, and then from the second we're going to do the same thing. We're going to run to the NOT gate, and then we're going to run all the way down to the A side over here. So what this means is as we go through and this system kicks off, is this latch here is going to get a turn off pulse when this latch is turned off, because as you can see it's currently turned off, and that means that this is turned on. This AND gate's going to get turned on when we hook it up to the actual input pulse, and then that's going to turn this latch off. Whereas if this latch is on, this system is going to be off, this one's going to be on, and this latch is going to turn on. So it kind of cycles that light or that sequence down through as we saw before. So the final thing we're going to do is we're going to run from the final latch through to the node that we set up before. this node is then going to run through into the NOT gate of the first, and of course the AND gate of the first as well at the A port. So as I said before, you can make this as long as you like. You could just keep running these down and down and down. All you need to do is make sure you hook it back through the latch, back through this little node to the first latch setup. Now once all of those things are hooked up, all it is time to do is now connect this input pulse to the B side of every other AND gate that exists. And that was the wrong thing that we want to hit, so just make sure that you're actually getting to the AND gates and hooking them all up. So here we go, into the B side of all of these, and we're just going to run, in my case that's 6 AND gates I need to hook up. If you're hooking up further than this, you just need to go through and hook up all of the AND gates, just to make sure you've got them all. If you don't get them all, then you're not going to propagate signals correctly, and you will find bugs in your program. So if you do start running one of these and it's not working exactly as you would expect, a light's not turning off or a light's not turning on, the first thing I would check is to make sure that this input pulse is correctly hooked up to all of your AND gates. So this is actually now a pretty much working circuit. The only problem is that there is nothing to copy down. So at the moment we've got everything off, and if I turn this thing on, if I give it a quick pulse, nothing's going to happen, because this gate is copying nothing from this gate, and then this gate is copying nothing from this gate, and then the first gate is copying nothing from the end gate. So what we actually need is we need a start pulse. We need to kind of kick all of this stuff off. So the way I'm going to do that is I'm going to place down a reset pulse. So the reset pulse is basically just a rising edge pulse hooked up to a single NOT gate. So I'm actually going to remove this guy out so you guys can see this pulse setup that I'm running. Sorry, I'll just quickly move that. So here we go, NOT gate there and AND gate here. So what's going to happen is we're going to run the first NOT gate into the second NOT gate into the A side of the AND gate, and first NOT gate into the B side of the AND gate. So this means that whenever a circuit is reset, this is going to give one really quick pulse right at the beginning, and that we're going to use to turn on the first latch. So here you go, as you can see, that circuit immediately reset as soon as we connect that line, because as I've mentioned before, circuits reset when the island resets, when new Lumostone things are being placed down, and when new Lumostone lines are connected to anything, whether that's the first input or the second or the output, doesn't matter. So here we go, now this thing is going to cycle correctly. If we stand on here, you'll see that the second latch copied the state of the first latch, and as soon as it did that, the first latch copied the state of the final latch, which was off. So now it is off. We step on this again. The third latch copied the second latch copied the off from the first latch, and the first latch copied the off from the third latch before it changed. So that's how this whole system works. Now, this does mean, of course, that if you really want to, you can actually set this whole system up to cycle through with different numbers of things. All you need to do is you need to take this kind of little starter pulse and run it into one of the other NOT gates. So if I run it into this NOT gate, you'll see that, that latch, you'll see now that we've got two latches on. When I step on this plate, those two are going to cycle through. So now we've got that on and that on. And if I step it on again, we've got those two on, and if I step on it again, it goes back to the original condition. Obviously, this would be a lot clearer if we actually place down our outputs, which in our case is a couple of Lumo lamps. But of course, this could be doors or whatever you like to make a interesting and unique puzzle where a user has to press on a single pressure plate multiple times to actually open a series of doors. And potentially you could have it so that behind those doors, different things had to happen before a final output is triggered. For some reason we've got a little bug with this lamp here, but you can see the effect I'm going for, and I've done that simply by adding this extra line here. If I break that line, we go back to having just a single pulse that runs through everything. And I've seemed to get the double trigger bug going on my pressure plate now. But there you go, that is how you build a sequencer. And this thing, it's a kind of a behind the scenes web. It's not probably going to be used to run an actual piece of puzzle, but I would suggest using it as a behind the scenes thing to make sure somebody's doing things in the order you want them to do them. I hope you guys have enjoyed that one, and I will see you in the next video.